did with Oasis Network. And as a conclusion, we're going to have the guys from the Flare Network presenting a bit what they are working on. So, yeah, without further ado, let's kick it off. Benjamin, the stage is yours.
Thanks, Patrick. So, yeah, my name is Benjamin. I came today from Germany. I work for the Deutsche Telekom, for the Web3 unit. And I'm really happy to be here today in Slovenia. I've never been here. It's a really beautiful place. And today I want to take you on a short journey on what we are doing in Web3, because probably most of you are wondering what is the Deutsche Telekom doing with crypto, right? So let's check it out. So yeah, our unit is called Web3 Infrastructure and Solutions. Probably you have heard of Deutsche Telekom, and our unit is called Telekom MMS, which stands for Multimedia Solutions. Right now we have multiple units at the Deutsche Telekom. So we are the biggest unit with about 20 employees, and we also have other units working on wallets, NFTs, and loyalty programs. So yeah, what are we doing with crypto? By the way, we love memes. So actually, you know the story, we are providing infrastructure since back in the days. We started early with voice communication, we were like connecting people, we were building telephone lines, and later on in Web2 we were connecting people with internet backbone, cables and servers. And so in 2016 we thought, there's a new technology, this is blockchain, maybe we have a chance here, maybe we can try it. And we started early with permissioned blockchains, hyperledger and stuff. And we learned our lesson, it was a really hard business, proof of concept. And we went back to our mission to provide open infrastructure for public blockchain networks. And so we started with validator services, staking and indexing. And here's our journey. So in 2020 we had our first Chainlink oracles, which was really special for us. We got our first footsteps into crypto, setting up nodes and getting in contact with foundations, because this is a whole another story than our typical business. Because normally we have clients who are like asking software, or we have to provide some services. Here we are working for a blockchain, which is so different. We have to serve, we have to perform, and we are getting paid by the blockchain. So this is a whole new business level for us. And we learned that we need community, we need to get closer, we need to go to conferences and connect. And later we hosted other networks like Flow, Chelo, 21 we had Polkadot, Q Network, Chelo, and so on. And we are really close with the Deutsche Telekom, with the communications manager. So we have the chance to publish press announcements, which is pretty cool. So maybe back in the days we have seen some press announcements from us, like working with foundations, and we could kick out cool press announcement and our clients, they'd be like, hey, Deutsche Telekom, there's a press announcement, you're working with Fetch. What are you guys doing there? You're working with Energy Web? What are you doing there? So our clients, they are watching us, they want to know what we are doing, and we have the first footstep, we are providing the infrastructure. So this is what I mentioned on the left, where we are like getting to press announcement, which is pretty cool that we have the chance to do so. And we also got our own Twitter channel from the Telekom. So it takes a lot of steps to get like social media channels internally going. And we are really happy to have our own Twitter channel, which has grown to like, I think, 5,000 followers by now. And also we get a lot of FOMO calls from our clients. So let's say some guys are working in the energy sector. We release a press announcement, hey, we're working with Energy Web. So we're getting a lot of calls. What are you doing there? What is the blockchain for? And also, we got our own, it is like a Geschäftskundenseite, so it's like the business side from Deutsche Telekom. And we have our staking side. So other corporates or clients, they can go to our staking side, they can choose our nodes and validators, and they can delegate the assets to us, which is also a pretty good step for us. Right now, I know compared to other startups, this is pretty small. We have 100 million plus on digital assets in our infrastructure from over 13 supported protocols. We have, I think right now it's over 250 validators, and our validators are online 99% plus. Also, we are using the open Deutsche Telekom cloud, which is really valuable because most of the infrastructure providers, they are dependent on hyperscalers like AWS and stuff. And once there's a problem, probably a lot of validators would get kicked out, but we have our own cloud strategy. So yeah, this is a short overview on what we're doing. We have staking services, Oracle services, indexing services with the graph, and so also other promising networks on Polkadot, and yeah, also Web3 consulting. So there are a lot of companies who are asking us, how can we get our first footstep into this, and what are you guys doing? And so we're telling our journey. We started with staking and proving that a decentralized way is a total new way of thinking. We have to get together. We cannot build our own island solutions just for us. We have to come together and build something together, right? Worldwide, we have 252 million mobile customers worldwide, 25 million landline connections, and 22 million broadband lines. And I think if you see all our customers and all our products, there's a huge chance to get them onboarded into Web3. So it's really important to make always the first step, and a lot of companies always they are looking at us. So if they're critical about crypto, blockchain, telecom is doing something with them, with those new technologies, maybe there's something to it. Also, we have a lot of challenges. When we started early with chaining oracles, we had, maybe you remember those crazy gas spikes, when you had to pay huge amounts of gas fees. And I mean, this was not even the highest day, but there was I think there was one day where we had to spend 150 ETH to provide our chaining oracles. And we had to call our accounting service, hey, we need more Ethereum, 150K. They'd be like, what? You know? So we have a lot of challenges, but we are getting better and better. So in the beginning, we were rolling out new networks really slowly, as we've seen in our journey. But now we are getting faster. We have our own legal department. We are really working closely to the press manager, and yeah, we try to see new opportunities, new networks, and to connect our clients to this wonderful technology. Nothing in life is more important than the ability to communicate effectively. Thank you.
So, do we have any questions for Benjamin? Well, I need to say, yeah.
What was the compelling, what was the trigger for Deutsche Telekom to go into Web3?
Actually, we had two colleagues early, and they started with Ethereum, and they were hyping it early, and they were like, you have to go to blockchain, you have to see it, it's a new technology, and then the ball starts rolling. So once there's a new hype going on or something, a new technology, we always try to have a look at it and get our first footstep in. And back in the day, there was the problem with refugee registrations in Germany, so it was difficult to track all that. And so we had the idea, maybe we can use blockchain technology to make this whole process more secure. And so we had our first proof of concept with Hyperledger, but the real kicker came with public blockchains, open infrastructure, and really secure and decentralized applications. But mostly it's pushed by internal team members who are like, hey, I've been to this conference, this is a new technology, check it out. And then we are really critical thinking, and the good thing is we are I would say a little startup at the Deutsche Telekom, but we are getting a lot of support. So I don't want to say we can do what we want. I mean, we have a lot of we have a lot of hurdles and challenges, but if we see a lot of value in something and we push hard for it, then we can just go.
One more question.
Yeah, so we've been to your offices during the Berlin Blockchain Week. How does your incubator work? Is it like board-based, or anybody coming in there with a good idea can get incubated with like Deutsche Telekom?
Yeah, basically everybody can go there and you can apply, and then I mean it's an open office, you can just go there and just connect and see what happens, right? So, I mean it's a different unit, we have hundreds of units at the Deutsche Telekom. You know it's hard to have always the overview, but that's from what I've heard. And it's a really good place for like conferences and meetups, so if you guys in Berlin, you can just come over and we can have a coffee or something, it's really cool.
Yeah, the offices are great.
Thank you.
Okay, well, one question in the back.
Any legal or compliance issues with being a validator, selling coins, buying them?
Yes, yeah. This is actually like a legal, we have our own legal department, so also tax is a huge problem. If you're working with foundations, we have a compliance check, we are all those foundations, and we always have to work really close with our legal department to check who are we working with. You know, this is basically the first step. And also like regarding contracts. So sometimes if we're having like new partners, it can take months since to get all the check marks done, right? So yeah, there are a lot of processes, but at the end we are really happy because so far we had no slashing incident, we had no legal problems, and some guy at the Berlin Summit he called us cycle proof. So we are doing this since 2016, and we are still here. So it's cool, right? So. And we have our running business. So there are other units maybe, we're like having like projects where they're like, I don't want to say burning money, but we are generating money, we are gaining revenue, which is a really cool business model. And yeah, probably the biggest part is the token sales. For example, we had to teach all accounting, like how to go with ledger and stuff. So it takes some time, but we are getting better and better.
So,
Okay, when you said token sales, do you trade your stacks, or are you active in the markets as well, or not?
No, we have like external service providers.
One more question from my end. So now you're presenting a bit like what we're focusing at the moment. What about the future? Like what are some future projects and steps that you're aiming to make?
The first stage is our infrastructure layer. So we are securing a lot of networks, we are helping them to get decentralized, and the next step is onboarding our other units and clients to build apps on it. So I think at the Berlin Blockchain Week someone asked me what's the word you would say is the most important for this year. I would say products. So we have to build products. We don't want to talk about what is crypto. You need a token to send transactions. No, we want to have a product which everyone can use. It's easier and more secure.
It's super nice to hear that we are all in the same boat. So once again, Benjamin, thank you very much. So for the next presentation, we need to change the theme here a bit. We need to change the color to blue because we have Matej Janes, who is the BT at Oasis, coming on stage. Yes, you can take the mic. Presenting a bit. Well, first, what Oasis does, and next presentation will be pretty interesting. It will actually be, I'm not going to say a conclusion, but a follow-up on the story that started exactly in this meetup, like 6 months ago, or maybe 8 months ago. So, Matej, just a second, let me prepare the presentation.
Yeah, please do. But thank you, Patrick, for this. This is very accommodating. I wasn't expecting to have the backlight in our clothes as well. Yeah. Okay, thank you, Patrick. And that's true. Yeah, we had a good conversation here over a beer, and then the idea came true. And then I think we struck a great partnership here where it's a great fit for you guys as well. And we are very happy that somebody's building this up. But we'll share more when we get there. First I want to say, great to hear really the presentation from Benjamin. Great to see the company stepping in. Hopefully we can get like a blue logo on that timeline as well. We'll see, we can talk later. Many ideas get born here in this space. First a quick show of hands. How many people know Oasis Network, or the Rose token? Oh shit, all right. Then I can skip the first 5 slides, I guess. We'll go briefly through it, maybe just a refresher. But yeah, it's great to hear that it's not going to be like a completely new thing for you. So yeah, when we speak about Oasis, we say, you know, we're the smart privacy for Web3 and AI, and we're going to a little bit dissect the whole statement here. So what is Oasis? You know, we started back in 2018 as a layer 1 blockchain with a slightly more unique architecture. Maybe not even that unique because we're the Polkadot meetup, so it's quite similar to the Polkadot ecosystem, except that with us, you don't have to you know, get a slot, get a parachain, right? You can deploy your runtimes as many as you like, but we do have the same separation from consensus to compute, right? You have the consensus layer to do just consensus, and then you have the compute layer where you do all the compute, and then you horizontally scale with as many paratimes, or how we call them, basically pair of runtimes. You scale the compute, and you can actually adjust, you know, in which tech stack you want to work, or you know, who's the validator on your runtime, anything like that, right? So, but basically what we decided to focus more on last year was on-chain privacy, right? We were always very privacy-oriented from the start, and then last year, after the last cycle, we saw that there's like a big congestion of alternative layer 1s trying to attract users, capital, but the on-chain privacy aspect was missing, right? And then we saw a lot of hype on ZK that got a lot of attention last year. We went with a slightly different approach. We think it's slightly more scalable, and it still has the right trust assumptions there. And we developed the runtime that we call Sapphire, which is our main focus right now, and we're going to dive a little bit deeper into what Sapphire is, right? So we spoke about this already. We have the consensus layer here, and we have the compute layer, which are various paratimes. But we did think about one more thing when we were designing the system is trying to attract users and liquidity to your own chain can be problematic, right? Especially for already established apps on, let's say, Ethereum, Polygon, BNB chain, or whatever. When they're there, when they need to move all of that over to use your features, it can be problematic, right? So we decided to also build what we call the Oasis privacy layer, which is basically a messaging layer where you can send encrypted messages to Sapphire, do the compute there, relay the encrypted message back to the home chain, and then the users don't really know that it utilized Sapphire in between for that confidentiality, and they just remain basically on their home chain utilizing the dApp and the native UX that they're used to, right? So, I'm ahead of my slide, sorry. So, we're here at the Oasis privacy layer. So, Sapphire network, home network, what happens is, you know, the user propagates a transaction, which is basically a signed message. They can actually avoid also holding the native token, right? So you can have like a gas free there, or you have the contract paying gas on Sapphire, so it's sponsored gas. So actually, the UX for users stays completely the same, while still having the confidential transactions there that you can utilize within your dApps, right? And we're going to go into the specific use cases later in the presentation. So I mentioned ZK before. What we're using, ZKs are okay for certain applications, but what we're using is TEs, right? So what are TEs? Trusted Execution Environment. That's like IntelliGX. Right now we're using IntelliGX because it proved itself as the most battle-tested one. You know, currently there are no known exploits for it, but it's basically, you have a secure enclave, you send the smart contract in, you send the encrypted data in as well, and then you get the encrypted result out, right? It's very secure, so basically we have separation of the key manager nodes and the compute nodes. So the compute nodes don't actually hold any keys, and also the communication happens within the IntelliGX. So basically, none of the validators actually see the keys, right? That's sometimes a worry when people think about TEs, right? It's like, okay, the validator is running them, but he can access the keys and just access my transactions. That's not the case here, right? So basically, it's everything. You can communicate between secure enclaves and nothing seen. So what we call smart privacy is privacy when it's needed, right? So you have selective disclosure and elective privacy. So you have the amount of privacy that you want. You can have fully transparent transactions or fully confidential ones. It's the spectrum, right? It's not one or the other. And then you can have public proofs of private data. Compliance and regulation are very, let's say, a worry of every Web3 project, right? Where they are sometimes worried about how to stay compliant and at the same time private, right? And here you can set up the contracts so you can grant access to certain contracts or certain EOA addresses, right? And certain things stay completely private for others, right? And this ties in with the transparency of the changing groups, or you have conditional access controls for, let's say, user data, right? If you have your data stored, let's say, on-chain, IPFS, whatever, you can actually then have, for each access to that data, you basically need to approve it from your account, right? It's not just generally shared. And it's all done by a smart contract, that's the beauty of it. So, how to apply this, or where to apply this, is basically you have confidential AI, private data management, DID, secret ballots, fully confidential ETL roles, secret options, gains with zero trust assumptions. That's very important in also gambling and private payments. And there are many use cases that we kind of chose these as more common ones. So recently we shifted our focus a little bit more towards AI as well, because we see that there's a lot of development with the centralized entities, doing a lot of it. You have OpenAI, you have Google Gemini, and then they're kind of taking over the whole space, and we want to be the counterparty on the other side, where we go with the decentralized version, trustless version, where you can be sure, where you can kind of have some assurance that how your data is used, how the models are being done, how it's being computed. It's not just a black box sitting on a Google or a Microsoft server somewhere, right? So we want to be in this space, help with the development of AI. We call it the crypto by AI movement, and I think it's going to be a good one. It's going to be a big one. It's gaining a lot of attention, and we already have some partners that are building in space, and we are all actually building an additional framework that will help a lot with the ease of usage and development of AI on chain, and this is what we call ROFL. So runtime off-chain logic, where basically for off-chain components, you're able to verify them on-chain through remote attestation, right? So you can be sure that the models, the data that's being used off-chain is actually the one that's supposed to be used, right? Because currently, how the agents and models are run is basically you have some off-chain components that you know nothing about, and then you get some on-chain result, right? And that's not the ideal case right now, because everything's still, let's say, the toy version, right? Where there's no real data, there's no real value there, it's not a problem yet. But once you get real value, real data, then this is crucial, right? That you can be sure that what's being computed off-chain is actually what's then being presented as results on-chain. So if you move now to the more specific use cases that people can relate to, right? We have one that's very prominent, one in crypto, and it's not being widespread used, it's confidential voting, right? Currently, all the DAOs are operating in like a decentralized governance system, but the problem is that all the votes are public. And then you have a lot of, let's say, at first going to have potentially sway of votes, because a large voter can basically vote one way, everybody can see that, and then they just follow him, right? So you have coercion of votes. Potentially you have also people not willing or open to vote the other way because people can see how they voted, right? So confidential voting to mimic how we vote in real life should be, applied in crypto as well. And this is where we see a big opportunity. We're actually building an app that's going to enable DAOs to run, let's say, like a side DAO, where you're able to do a temperature check within your community and see what they think about the topic in private, right? So it's going to be released quite soon, and it's going to have token gating, so you kind of have the whole DAO functionality but at the same time, you don't need to fully integrate it yet. But we are working on getting it integrated with the bigger DAO tools as well, like Paragon DAO House, to simplify the UX for everyone there. You just scan the QR, it takes you to a demo app that we have there, but that's going to be upgraded fairly soon, so you can follow our playground where we post the demo apps, and there you can basically check all the use cases that are being presented here. Anyway, scanning, or I can go forward. Okay. Then sealed auctions is also one of the interesting ones, where basically currently how the sales happen, let's say NFTs, right? You had a lot of, let's say, first sales when the prices were fixed, so you had no price discovery, and at the same time, a lot of, let's say, a lot of attention, or a lot of users wanted to buy that, so you had gas wars, as Benjamin was saying, right? During certain periods, there were huge peaks because of certain NFT releases, right? If you have sealed auctions, you have a truer price discovery, because you can basically see how much people are willing to pay for a certain NFT, let's say, or a certain, let's say, slot of tokens, right? But at the same time, it can be open for a week, and you don't have the price wars, right? You can just send in your bid whenever it's optimal for you, right? So this is, we believe, a very, very nice use case, and this all can be used cross-chain. It's that the beauty of it, right? You don't have to move your users to Sapphire or deploy NFTs on Sapphire, right? You can stay where you are, you just have the bidding contracts on Sapphire, and then use the messaging bridge to basically send the bids, right? And have the bidding auction be there, everything else is on your own chain. So this is really neat for any already established app, right? If you move forward, one interesting use case is also private trading, private accounting. We already have the DAX deployed on Sapphire, which enables private pools, so there's no front running, no MD, and also you can kind of hide, not that necessarily the liquidity, but predominantly it's this, right? You can actually hide the trades that are happening, right? But one more interesting use case that I see with this is actually with cross-chain derivatives, right? When you have a derivative exchange like GMX on Arbitrum, right? Currently, your opening positions, long, short, whatever, right? Everybody can see that, and they can also see where's your liquidation point, right? If you're doing trading private, nobody can see that. And again, you're not necessarily needed to send funds over because it's derivatives, right? It's just accounting. So you can keep your name and your tokens on an empty chain, but then just do the accounting in Sapphire. You're just doing, okay, he went long short here, he made this much, he went short here, he made this much, lost this much, and then you just you do the reconciliation at the end on the home chain, right? So a lot of really interesting cross-chain use cases that can be used here. I'm gonna go quicker here because we have a demo as well, so I have to worry about all the use cases. But yeah, confidential NFTs is one where you can have private metadata to an actual NFT, right? So if we look at the whole NFT, let's say, craze that happened, right? And then the right-click savers, right? Where people write, why are you buying the NFT if I can just right-click save your image? With confidential NFTs, you could do is, you could have a low-res image on the public metadata, and then like a fully blown 4K image in the private data, right? And then only the owner is privy to that private image, right? It can be PFPs, it can be art, whatever, but it adds some benefit to the owner that's not visible to everybody. And honestly, gaming, very large spectrum. I would say currently it's not, the gaming needs a lot of privacy, right? Fog of war, secret trades, verifiable randomness, but currently how they're doing it is just, they have a lot of logic off-chain already, so whatever needs to be private, they just keep it on the service, right? But I think for true, verifiability and trustlessness, especially in, let's say, gambling, right? This logic should be moved on-chain so you can verify, you can trust it, and you're basically, if you're playing, that nobody in the back is corrupting it or, changing your cards. I think we're coming to the last one, the most important one, and that is the Oasis Account Abstraction. So we heard a lot about account abstraction at EIP 457, right? But that EIP is focusing mostly on who pays the gas, right? And then you still have to deploy all the contracts everywhere. We have a slightly different spin on account abstraction, where because we have private smart contract storage, you can actually save the private key of the wallet on chain. And then you tie a different authentication method to that private key, right? So you don't lose the trustlessness, the centralization of it, but at the same time you simplify the UX because you can tie your fingerprint, your Face ID, your YubiKey, email, password, whatever, to that private key, right? Then onboarding new users is very simple because it mimics the Web2 onboarding, right? That they're already used to. So I'm not going to speak too much on this topic. I'm just going to let Damien show what they did. But yeah, this is one of the strongest one, and I'm very happy that we're doing that with Apillon, and hopefully we get the final product out soon. Thank you. That was long, sorry.
That's good. So before we're going to proceed, questions? All right. So yeah, just one thing. I need to say, me being a growth manager at Apillon, I'm super thrilled about the account abstraction SDK that we're building on top of Oasis. Just because, like in the past, we've seen what it means when you expose like non-Web3 people to wallets and like to private keys and everything. It's really a mess, and this collaboration will definitely help to ease out the user onboarding. So yeah, but thank you very much. And yeah, the next presentation will be from Damien, who is our backend developer. Just give us a minute to please set up the stage. Okay, Damien, so the stage is yours.
Hi everyone, my name is Damien, I'm a backend developer for Apillon, and what we're going to be talking about today is the custom solution we built in collaboration with Oasis, which we call embedded wallets. Before we begin, let me just tell you a short introduction story here. So let's imagine this, you're a developer and you've just built one of the greatest apps out there. Revolutionizing finance, DeFi, RWA, DePIN, all the buzzwords are in there, right? So before you want to ship it to the world, what you want to do is gather a couple of your friends to show it to them and gather the feedback to see if it's ready or not yet. So the scenario is, let's say you sit them down and you start showing them this app, and so they go onto your website and want to use it. And then one of them asks, wait, what is this? I need to download something here. And you tell them, yeah, you need a wallet to use this. And they ask, why do you need my wallet? No, it's a digital wallet actually. So what happens next is they ask, I need another app, to download another app in order to use this app. That's right, makes sense, right? So as you go through this process of explaining them why they need to do this, they come across, of course, inevitably to setting up their own seed phrase and private key for this wallet. And that's where you start getting into the deeper levels of explaining about what private keys are and what seed phrases are and why you need to store them securely. And by the time this is done, they're probably already wondering why they were your friends in the first place. So what's the conclusion here? Clearly, wallets and seed phrases are still a big friction to onboarding users. And if you want to reach mass adoption, this is clearly still a huge hurdle. I mean, can we really expect the average person to wrap their heads around what is a digital wallet and what is a seed phrase all in one sitting? And is it even a fair expectation if all they need to do is use some application on the internet. So this is where Apillon shook hands with Oasis to deliver a solution which will reduce this barrier of entry to other users which are not maybe that technical or have not yet been met with this kind of jargon. So what we've built is a solution called Embedded Wallet, which allows the developer of any application to allow users to actually abstract their a digital wallet for the users, so that they can just interact with the app the way they would usually and not require a digital wallet to have set up. So what does this do? It enables it greatly increases user experience, right? Because the user would not need to install additional applications or additional extensions and have some of their private keys stored elsewhere in order to use an application. So the way this works is the user already uses the same flow they're likely already used to, which is an email login. They enter their email, they get sent a verification link which verifies their email, and afterwards what they're asked to do is just to set up a passkey. So a passkey is just a credential which gets verified according to your biometric data, which can be either a press of a fingerprint on a laptop or scan with your face on your mobile phone and so on. So this has many additional benefits besides increasing the user experience, which is, let's say you have this passkey stored on your phone. That means that you can go on any website and use the same passkey to get access to the same wallet, or even when you go on a different device, let's say you get a new laptop, you don't need to now go and import all your seed phrases once again, so you can get access to the same wallets again. Another benefit is maybe a very big point for new users, which is this is safe from phishing attacks. How? Because a passkey is tied to the domain of a website. So if I create a passkey for Apillon.io, that means the wallet that I get for Apillon.io will be only for that website. And if I somehow fall into a trap of hopping into a clone of Apillon.io, which is called Apillon.io, that means my passkey will not work for this website anymore, and I'll be sure that I can't, nobody else can get access to my wallet that way. So just for a quick comparison here, these are some of the other most reputable providers of a similar solution. So some of them call it in-app wallet or smart wallet. The main points here are that we offer different kinds of authentication methods, multiple kinds. Our wallet scope is global, which is also a very good point to make about user-friendliness, because the other providers would only allow you to have one wallet per website, and if you use their same solution on a different website, then you would get a different wallet, which might be kind of annoying for users to have to transfer assets between wallets. What we do is we give you always the same wallet for the same email address and passkey, and it's completely decentralized by the Oasis confidential smart contracts. Let's have a peek how this works under the hood. So a new user would onboard onto your dApp that you built, and by using the Apillon SDK, you would send a request to the Oasis blockchain, which would generate a new private and public key pair for you. And this private key is stored on the blockchain, which is private and stored in an encrypted way, which can never be accessed by anybody. And when you need to make a transaction using your wallet on the dApp, actually what you just do is you present your passkey. So either you tap your finger or you scan your face, and the transaction is being sent. And what happens under the hood is Oasis verifies that your email and your passkey combination belongs to a wallet address, and let's say it kind of works similarly to a cold wallet, where the transaction data is sent to the smart contract belonging to your address, it gets signed, and then the signed transaction data gets sent back to the client, where it then gets propagated to the blockchain later on. So your private keys never get exposed, and are never sent to the client unless you want to export them. And that way, the user, all this whole process of private keys gets abstracted away from the user, and they have a similar experience to what they're previously used to. Okay, so it's time to show how this works, and so I suppose you all know the one and main rule of live demos, which is never do a live demo. And that's why we have a recording. Great. Okay. So here we have classic dApp. So the UI is not there yet, but this is just to showcase how it works under the hood. So let's say the user comes onto your dApp and wants to sign in, and we first get presented with is to enter our email address. After we do, we get asked to verify it by typing in the code that you get on our email. And now here's where the key point happens. So this is actually a system request. It's not part of the website. This could happen depending on the device you're on. So I have a few choices here. I can either use an iCloud keychain, because on a Mac and for all iCloud devices, you are available to use this iCloud keychain, which is like a password manager. I can either use my phone to scan a QR code and then store the passkey on my phone, or I can use my Brave profile. Since I'm using Brave, I can store this credential on my Brave profile. And that's how then the passkey gets generated and stored on your device of choice. For the sake of simplicity here, I choose Brave profile since it will be easiest. I confirm that the website and email is correct. And now I'm just getting asked to present my fingerprint. And that's the point where the passkey gets created and sent to Oasis in order to create your wallet. And after that gets done and gets processed, I get back a new wallet, a completely new wallet just for myself, which is stored on the Oasis private smart contract. And here I have my new wallet that was just created. So let's copy it and just let's see how signing a transaction works. So let's sign a message. What I need to do, just tap my finger. That's it. No need for extensions, no need for any pop-ups to sign transactions with some cryptic data. And now also I'm using the Oasis network faucet for the Sapphire testnet, the testnet version of the Sapphire, to request some test tokens just so we can see how it works to send some tokens to another address. So let's say this is part of the app that you need to send tokens to somebody, entering the address and entering the amount, click transfer. So I want to mention that this could be usually something where we display something more user-friendly to the user. Let's say he's sending these unwanted tokens to this address. But now for the purposes of just demo, this is the raw transaction data that is being sent to the smart contract on Oasis. And this transaction data will then be signed using the private key, which is stored on their blockchain. And all I need to do was again just tap my finger, and the transaction is broadcasted on the network. Here it just takes some time to propagate, but after a while we see that the transfer was successful to the address that I put in previously. That's it for the demo. And that's also it for the presentation. So this is a QR code for our platform, if anybody is interested in signing up. Other than that, that's it, and thank you for your attention.
So yeah, I hope you're as excited as we are. Any questions for Damian? And the first one directly from Matej. Okay.
No, sorry, I didn't mention, and it was mentioned here as well, but the option here, because the private key gets stored into the smart contract storage, right? It's that you're not limited to 0x addresses, right?
Yeah.
So maybe that's one thing to mention. You can store Bitcoin addresses here. You can store Polkadot specific addresses. And are the plans on supporting that as well, or is this like a V2 or?
Yeah, there are also plans to implement a substrate version of this. So this is now for any EVM chain. On this demo, we also have a Moon-based version supported, but just to not make it long, I didn't show it. But after on later, we will also implement support for substrate-based addresses. And maybe another important thing that I forgot to mention is that we have, for this, there is a pay master smart contract, which means that, as you already saw, the user does not need to pay any fees to create this wallet. This is all taken care of by the smart contract on Oasis.
One question in the back.
Yeah, what is the latency of the sign? So how fast the sign could be applied?
6 seconds.
It's pretty fast because it's only
It's 1 second, 2 seconds, because of the latency for the trading is really kind of important.
What trading?
Matej is saying 6
So
seconds.
block time is 6 seconds.
Block time is 6 seconds, so you can wait 1, 2, 3, 4, 5. No, the sign, just the sign. So when basically you are sending the transaction, this transaction needs to be signed.
Yes.
And the private key is on blockchain, right?
Yes.
Just the sign. How
That should be fast because it's a query. It's not a line. It's just a query to the smart contract. So it is pretty.
No. So what he's saying is, it's a query.
Yeah, it's not a query.
It's
It's a query to the smart contract. So you just send the transaction data. It replies back with the transaction data signed.
Why I'm asking that, because I used to work with on MPC wallet provider, and it's like 3 seconds just for the sign, and this is like instant.
Yes.
Very good.
I was saying 6 seconds is when the wallet gets propagated because it needs to store the private key on the blockchain, so you need to wait the 6 seconds now. Yeah.
Okay.
Or maybe 4x, or Des was saying. It's not
Okay.
just, I guess.
Thank you.
Thank you, Damian. So, yeah, it will be very interesting to see the product in the Deutsche Telekom portfolio list. I'm just going to leave it there. So, okay, let's go to the last presentation. Let me invite on stage Philip, who is a developer relations at Flare Network. So, yeah, Philip.
Thank you. Okay, so hi, I'm Philip. I'm the head of the area here at Flare. What is Flare? Well, we're a blockchain for data. So what does that actually mean? So what is data? And we'll quickly go through what data is, how do you define and how do you use this data, and what can you then do on top of that. So, Okay, so just shortly, Flare is an EVM compatible layer 1 network. How many of you are familiar with those words? Okay, so EVM compatible, we're proof of stake network, approximately 1 to 2 seconds block time, low transaction fees, and one important piece of being EVM compatible is the fact that you have access to all the existing tooling. So the guys here at Apillon are building an amazing website and you can work with stuff and you can easily integrate blockchains, and being able to tap into an existing ecosystem or an existing product suite is really important. So starting a new blockchain, having the ability to just reuse EVM, reuse Solidity, reuse all the hard hat tooling, that's an important stuff. And what's really different is the fact that we have those two things. Real-time pricing data, secure, safely and directly on chain, and also on-demand external chain, and soon, so in a few months, on-demand information about what's happening in the real world, not just on chains, but also on websites, real-world assets and stuff like this. And because of all this stuff, what's available on Flare, so we have a large DeFi ecosystem, and you have all these nice things. So account abstraction, tokens, ERC tokens, NFTs, stablecoins, all stuff like this. Okay, so just shortly about us, so starting out, if you held any Ripple in 2020, you probably have received some airdrop. We shipped Songbird, the Canary network for Flare, in 2021, and we immediately shifted the community to DeFi. So we had FTSO on-chain, we have the pricing data, so immediately the main shift was DeFi. So what do you do on-chain with prices? DeFi. The technology, we use the Avalanche consensus nodes and EVM chain. We didn't want to build this ourselves, so we want to reuse as much as possible. And the main differentiating factors are those two oracles, currently enshrined directly on the protocol level on-chain. So you can differentiate between the chain and the oracles. They're immediately there for you to use nicely, efficiently, and they don't hog the network, which is also an important thing. So you don't have problems, you don't have latency spikes because of the oracle activity. The network progresses independently of this. So the two oracles, one is FTSO, the flat time series oracle, tries to answer the question, what is a price? So we're constantly broadcasting a price on the network. In the current version of the FTSO every 3 minutes, in the update that is currently already active on Songbird every 90 seconds, and in the update that's currently being tested on Songbird every block. So what is the price of an asset in some 90 seconds range? The answer is actually pretty difficult. So what do? We use a consensus among a group of people we call data providers. We're going to come to that at some later point. The data providers effectively submit what they think the price of Bitcoin, price of gold, price of some specific stock is. And then we take the weighted median according to the voter weight, according to the previous performance, and all additional parameters. And at the end of this 90 seconds price epoch, we say, okay, this is the current price available on network. Why is that important? Well, you have a pricing system on network, and you don't rely on any specific price point to price Bitcoin. This is good because having a big group of people submitting price and having them weighted and having them sorted and ordered by their vote power means that they are also sourcing those prices from different data points. So that means that if Binance goes down, you can still be sure that they're sourcing prices from other exchanges, because at the end they're getting rewarded by how good their final price is. So they're always competing against each other, trying to gather as much data as possible from different exchanges, aggregate it and try to put the correct pricing, while also having to think what to do if there's a problem in between. So because there is no difference between Binance API coming down or Binance itself submitting a bet, calling a bet price or something, the bet pricing from some data point, from CoinMarketCap, from Binance, from Bitstamp, from somewhere, is handled by the data providers themselves. If there's a spike on some market, they disregard it immediately because it dampers their ability to be rewarded. So if you remember, what was it, December 2021, when everybody was a billionaire, when CoinMarketCap said that Bitcoin was worth all the zeros possible, but data providers immediately noticed that one of the data sources they're using performed badly, disregarded it, and we didn't see any of those spikes. Even when the stablecoins depegged and some markets started to provide various different prices, they immediately noticed this and started to converge to the median price that is used in the pricing system. So with that way you can have a consensus about what the price is, while also being very resilient and be sure that the data is safe. There's no single point of failure. So that's the answer to what is price. And of course, 90-second prices are not that good. So we want to have a pricing stream that is constant. What do we do then? Well, we split the data providers into smaller groups and randomly select a few of them to allow them to minimally update the price, either up or down. What this allows us to have a small random sampling with people being able to push the price either up or down slowly, and even if they were to cheat, even if they were to act maliciously, the next data provider that would be chosen would adjust the price into the proper range. So this way we have a constant pricing stream that is again safe and secured by the staking in the system, and even if you have a small set of malicious providers, the others are always moving them into the right direction. And in that way, so this is the new and upgraded version, in that way we've moved the timing from 90 seconds to per block range with fast updates when user can on-demand request intermediary updates and higher values. So in that case you have a nice economic stability when you have some sort of users on one side requesting new updates periodically and requesting a higher variance, and data providers on one side providing data and being able to constantly chase this price point, which is getting rewarded. So that's the pricing. You got fast prices, you got fast data. for what is a probabilistic data source. So price does not have a real true definition. There's always some arbitrage between different exchanges. But sometimes you want to pose a question and get a deterministic answer for that. Sometimes you want to say, okay, I paid you something on Bitcoin. Can you prove that this exact transaction has happened? And can you then act upon it? Well, that's when the state connector comes in. State connector is the second part of this Oracle system, again enshrined directly in the system, where instead of data providers, you have attestation providers which attest that some specific deterministic query really has a correct answer. So in our case, let's say I want to attest that a specific Bitcoin transaction has happened, I pose a question. Did this Bitcoin transaction with this hash transmit X Bitcoin from A to B? And then when I execute this on-chain, each attestation provider goes, checks this Bitcoin transaction, which is specified in the request, checks that the results are exactly the same as I have proposed, and then attests to this on-chain. And again, because we bundle those roles, we bundle validators together with data providers and attestation providers, we are sure that the vote saying, yes, this transaction has indeed happened somewhere, is again backed by the stake in the system. So what you want to have, you want to have a big group of attesters attesting to the deterministic queries and be sure that they're not cheating the system. And again, having a big group of these, having stake in the system allows you to be Sybil resistant and also allows you to be sure that this data is getting included. So currently, the FTSO system supports 52 different data feeds, so you have mostly crypto pairs, we also have some commodities and some currency exchange pairs, while the state connector supports Bitcoin and Dogecoin, some UTXO chains, which were quite difficult to implement. It also supports XRP Ledger, so remember the thing about Terra beforehand, so XRP Ledger was important in the beginning, and we also support EVM chains. EVM chains are special. Why? Because you can do computing on top of them. So with EVM chains, it's not only did this transaction happen, it's also what was the state change in this transaction. So in that case, you can attest to a full state change together with the events that were emitted inside the transaction. So you want to know on Flare if some token was transferred on Polygon, it's simple. You just submit a request, did this transaction emit this specific event. The state connector verifies this, attests the full data source, and then at the end what you do, you just use this data on Flare and execute some compute on top of it. It's an EVM layer 1, so you can do whatever you choose inside those gas limits that are imposed by you. So what this means that you have data from multiple blockchains aggregated into one simple blockchain, and using the native relay, which we also support, you can push this data to other chains. So you have a security layer in the middle, allowing you to compute on top of data, while still being able to get this data in a verifiable way. So that's the nice stuff, how you can do this, what we all support. But, then there's stuff you can build on top of this. So we're building layer 1, just like Oasis. And the important thing is, you have all this infrastructure, you have the roads, you have the pipeline. What can you do on top of this? So, of course, DeFi, DEXs, per DEX, options, all this powered by FTSO, this is already on-chain. You have cross-chain swaps, you can attest the swap on. You can attest the transaction on one chain, on another chain, and you have a native swap that is again secured. You have assets which were released as a public beta just a week ago, which are data neutral synthetics. What you know that a specific Bitcoin transaction has happened, so you can use a collateral system to log Bitcoins on Bitcoin and then issue fully wrapped Bitcoins on chain without ever having to go to a centralized third party and trusting them that they hold Bitcoins. And stuff like this. So you can do a bunch of stuff. You're connecting chains and you have data available for this. So a few things in the pipeline that we're building, and some guys here are helping us. So we're generalizing this attestation type. So if you can answer the question, has this happened on Bitcoin? You can also answer a specific deterministic question, is the Bank of Slovenia website reporting something? Is the US Treasury reporting this specific number as inflation? Is the US Treasury reporting this specific number as the new Treasury bills issued? And stuff like this. And again, with this set of attestation clients on State Connector, you can prove this data and act on top of it. And this pretty much opens you to a world of data you can access. And importantly, since these attestations are effectively just off-chain computations, you can attest to inference run by models. You can say, okay, if I run this specific model on this input data, has the inference arrived at that specific result? And you can use this to further secure the network and run inference to secure the validation itself, or you can run inference on external data, big data, huge amounts of data that are unsuitable for EVM chain, and then push this directly and compute on top of that. So those are the things we're building on. And yeah, important stuff. So how do you come to this? All this is really fun and useful and very important, but how do you achieve this security layer? So how do you make sure that somebody is getting you the FTSO data? How do you know that somebody is giving you this validated data? How do you know that somebody checks a Bitcoin transaction and says, yep, I see it, and doesn't just answer, yep, I see it without checking it? So what we did, we bundled the roles. So you have the original blockchain validators, so the one that confirm transactions, and we also have these FTSO data providers, sourcing pricing data from multiple websites, and attestation clients answering those yes/no questions from other chains. And what we do, we bundle them in a single role. So if you want to be a validator, you have to do all those three. If you want to earn validation rewards, again, you have to do all those three. And there's a bunch of tooling that you need to build to support this. But this also opens up a huge amount of external collaboration and possibilities. For example, one of our biggest and most important data providers is Google Cloud. Because effectively what they do, they already run a bunch of external RPC nodes. If you are, and they can easily access them to also provide State Connector data. If you are, for example, a big Southeast Asian currency exchange, you already have Bitcoin nodes, you already have Ethereum node, you already have all this, and it's easy to tap into this and also provide the data. So getting all these validators on board and getting them to build with us was quite a step, but now this is the core layer of security. So they have huge institutions providing you this data, because you have 100 of them, you can be sure that this data is getting self-secure. And also, on top of this, you have all this rewarding infrastructure costs and how to productize this. But what we're really trying to do, we're trying to get those big people that already use data, already have this data to use it. Going back to the community, we also have a bunch of small shop validators that are running this, and they are interestingly very competitive with providing the correct prices compared to the big ones. And so just a few words how to make this work. So as always, layer one, what we're really trying to do is trying to attract developers. So we have data, we have all this fun stuff to build on top of it, but now we're looking for a project and we're working really hard on this. What that means, it means you need to build an SDKs, you need to build all the tooling, you need to build all the visuals, you need to build the monitoring system, firstly for people to observe what kind of data you have, for people to know that this data is good, that this data can be verified, and this data reasonably represents what's happening. And also you need to be sure that you're able to go through your historical data and make sure and properly analyze that the protocols you've built have really held up to the test of time. So you need to go back a month, 2 months, 3 months, and check that your data has been correct, even, I don't know, when market moved, when Bitcoin had a big fork or something like that. So this is really important, and we're working really hard on this. And maybe just a few things. So where are we? We started the mainnet in July 2022. So FTSO, the pricing system is fully operational. The quick prices, the defense updates are currently in testing phase of the Canary network. And the State Connector, so being able to attest the data from other chains, is alive for a bit more than a year. We're building a bunch of these non-Web3 adapters for State Connector, and they're getting more and more general. But we're currently working with some open banking prototype, a generic web connector to access different web pages, and so on. And we're also building an automatic relay to other chains. So not only having a security layer on one chain, but being able to push this outside. And yeah, what's the limit? but there's no limit. So having data, having connectivity, of course, AI, so off-chain computing, being able to offload all these amounts of computation off-chain to big data centers, that's always useful, RWA, and at some point, as a chain, you also have to check if your consensus, if your nodes, if all the infrastructure you're running are really suitable for this. So probably at some point we'll have to take a look at the nodes at the consensus level and see if we'll have to scratch some consensus parameters and maybe change the consensus a bit to be able to adapt to our protocols a bit better. But currently, we're quite good on having those protocols optimized and being able to have those protocols totally independent from the other chips. So the protocol execution, the data on chain, all this does not hamper the performance on chain, which can be problematic for some other stuff. Yeah, that's it.
Okay, so before we conclude, any questions for Philip? And again, Mateo, one question.
I have one question. Do you also do liquidity or just price?
Just currently just price. So sourcing the prices is actually quite expensive. If you want to have a block level price update, that means that everybody has to know what the price is at every block. So liquidity is best offered as a one-shot liquidity. So I want to know specific liquidity at that point, and then you get it at that point. Otherwise, you always know the liquidity, and that's just too much data.
Yeah, because sometimes price is, slippage is a big thing, right? So price can be one thing, but then if you can liquidate that much at that price is another question.
Yeah, but that's right. So you have price, if you want to know liquidity, that's a one-shot deterministic question.
Well, you can get it from your platform?
Currently not. I mean, it is generalized web to get yes.
And one more question, in terms of data, when you say, these applications, can you handle private data as well? So the data providers don't see the data and validate it it's true? Or?
No, currently the only way to handle the data is by having everybody being able to see exactly the same thing. So we're exploring the ability to have some sort of ZK on top of this, so I'm only exposing a bit to some people and then you can aggregate this, but currently it has to be fully done.
I have a better solution for you than ZK.
I mean, integrating a new chain is easy. So.
Yeah, no, the RAWFul framework does just that, right? So it enables private data verification without the other actually seeing the data.
All right, any more questions? So, this is it for today. Thank you, Philip. Thank you everyone for coming. I need to say that I'm super happy that we managed to put together 2 layer ones. Amazing, a huge enterprise. And of course, it would not be possible without Apillon. So thank you all for coming. Thank you all for being on live stream on Oasis. And see you next time. September.